All right, welcome to The Explainer. Today, we're diving into a professional, documentary-style look at Apple's history, but we're doing it through the lens of its absolute most powerful protagonist. And no, it's not a person, it's custom silicon. We usually think of Apple in terms of that sleek industrial design, right? The glass, the aluminum, the titanium. But the real story of their total dominance over the last decade, that's actually written in microscopic circuits. So how exactly did a company that started out in a dusty garage end up building literally the most advanced silicon on the entire planet? Let's unpack this central mystery. We're going to trace how a personal computer maker somehow evolved into an apex chip designer. It's this wild narrative of control, extreme efficiency, and just relentless engineering that completely rewired the tech landscape. Okay, part one. The mobile revolution begins. From the garage straight to the iPhone. So, tracing the timeline from 1976 up to that iconic 2007 iPhone launch, it's a dramatic prologue we all know pretty well, right? Apple was fundamentally defining modern computing. They were just pushing out massive paradigm shifts one after another. But, and this is a big but, underlying all that world-changing momentum was a pretty critical vulnerability. They were entirely reliant on outsourced, third-party processors. Basically, they were building the vehicles of the future, but they didn't actually own the engine. And that tension, it completely peaked in 2007. Now, the original iPhone was undeniably a marvel. I mean, that multi-touch interface changed mobile communication forever. But under the hood, it was surprisingly constrained. It was actually powered by a third-party Samsung chip, running at a mere 412 megahertz. Apple had designed the perfect shell, the perfect software, but the actual processing power, that was completely out of their direct control. Which brings us to Section 2, the custom silicon shift, taking control of the core. Enter the Apple A4 in 2010. Guys, this was a massive, massive turning point. Debuting in the original iPad and then the iPhone 4, this was Apple's very first self-developed processor. Looking back at it now, the A4 was essentially a Trojan horse. It was introduced quietly for mobile devices, sure, but it was secretly serving as the foundational training ground for what would eventually become their ultimate superpower in global chip design. Now, by today's standards, the A4 was, well, incredibly modest. We're talking a 45-nanometer manufacturing process, just a single-core architecture, clocked at 800 megahertz. It was really just designed to handle basic mobile apps and simple games. But here's the kicker. Its relentless focus on energy efficiency, squeezing the absolute maximum performance out of minimal battery drain, that laid the exact blueprint Apple would stubbornly follow for the next decade. Moving into Section 3, from the A4 up to the A17 Pro, exponential evolution. The juxtaposition between these two is just staggering. We jump from that A4 in 2010 all the way to the A17 Pro in 2023. They shrank the manufacturing footprint from 45 nanometers down to a microscopic 3-nanometer process. To put that into perspective for you, a single strand of human DNA is about 2.5 nanometers wide. It's crazy. This mind-bending miniaturization allows the A17 Pro to pack in billions more transistors, leaping from a single core to a highly advanced 6-core setup that just eats complex multitasking for breakfast. So the crucial takeaway here is really the sheer absurdity of what this tech achieved. This phone-forward chip, sitting right there inside the iPhone 15 Pro, pushes 51 gigabytes per second in memory bandwidth and even features hardware ray tracing. Think about that for a second. It makes actual console-level AAA gaming possible right in your pocket. And it's doing it in a passively cooled device. No fan. It is a massive testament to the hyper speed at which Apple's silicon team was iterating year over year. All right, Section 4, the Mac's second life, scaling up to the desktop. In November 2020, Apple made this monumental shift away from Intel over to their own ARM-based M1 processor, bringing that highly efficient architecture straight to the Mac. Honestly, it was a massive industry risk. A lot of skeptics were wondering, could a chip architecture originally born for a smartphone ever actually handle exacting pro-level desktop needs? But as we all know, the arrival of the M1 completely changed the trajectory of the Mac forever. And it was an incredibly methodical rollout. For step one, Apple literally took A12Z chips straight out of the iPad Pro, slapped them into Mac mini cases, and handed them over to software developers just as a test environment. Then, step two, they unleashed the actual M1 in familiar entry-level designs like the MacBook Air. Finally, step three, Once that foundation was totally proven, they aggressively scaled it up, bolting on more cores to create those massive M-series Macs and Ultra chips for the truly intensive pro workloads. Of course, hardware is pretty much useless without software. So to prevent a catastrophic software apocalypse during this massive transition, Apple built Rosetta 2. This translation layer was so unbelievably efficient that older software, stuff compiled specifically for Intel, often ran faster on the new M1 chips than it actually did on native Intel machines. I mean, it was basically a seamless magic trick that kept the entire software ecosystem thriving without missing a beat. Which leads us perfectly into Section 5, Apple's Silicon Supremacy, redefining the industry. Just look at how they haven't dropped the ball since that gigantic initial leap to the M1. Through these really steady 10 to 30% generational speed boosts, Apple's base M5 processor is now roughly twice as fast across the board as the original groundbreaking M1. It's this relentless, almost clockwork-like improvement in performance that just leaves competitors completely scrambling to catch up. And this really brilliantly illustrates how the efficiency of Apple Silicon scales. On one side, you have the architecture powering a single, fanless, ultra-thin MacBook Air. But on the other side, because of that extreme energy efficiency and super low heat output, that exact same architecture scales all the way up to run massive continuous integration server racks in enterprise environments, like those huge Mac Stadium data centers. The flexibility here is simply unmatched. Furthermore, Apple has rapidly pivoted these designs to meet the absolute bleeding edge of tech. They baked neural accelerators directly into the M4 CPU cores, and then the M5 extends those accelerators right into the GPU cores. By tightly integrating massive amounts of high-speed memory directly on the chip, they're specifically tuning the silicon to handle the heavy, on-device processing required for modern AI workloads, and they're doing it perfectly natively. Now, why does all this crazy engineering matter on a macro scale? Well, this vertical integration, owning the hardware, the software, and the silicon, was a massive financial catalyst. It directly helped drive Apple to become the very first publicly traded company to reach a staggering $1 trillion market cap back in 2018. It fundamentally proved that controlling your core technology from top to bottom is the ultimate business advantage. So, after witnessing this incredible journey from that modest single-core A4 to the towering M-series titans powering data centers today, we really have to ask, what happens next? What new frontiers will Apple cross now that they completely own and dictate every single layer of their technology stack for the next decade? It's going to be wild to watch.